For today's assignment, you're given a description, and you're going to use that description to write a linear function or a linear equation. For many of us, this is going to be a difficult task to do. So what I'm going to do is I'm going to complete number 1 and number 2 with you, and then I'm going to help you get started with 3, 4, and 5. And then hopefully after seeing these 5 problems, number 6, 7, and 8 become a little easier. Let's begin with number 1. The description for number 1 says the graph of the function passes through the point 2, comma 1, and y increases by 4 when x increases by 1. So a reminder, we're writing a linear function, or what we can call a linear equation. And when I think of the word linear function, I think about what does a typical linear function look like? And that would be the form y equals mx plus b, where m is our slope and b is our y-intercept. So I need to figure out these two pieces of information in order to complete these problems. Sometimes this information will be given to us in the description. Sometimes we'll have to use the given information to come up with this slope or this y-intercept. For the first problem, the second part of my sentence tells me y increases by 4 when x increases by 1. This reminds me a lot of a slope or a constant rate. When I think about a slope, what does the slope represent? It represents the change in the y, which we call the rise, divided by the change in the x, which we call the run. And this is what they're describing. It says the y increases by 4 as my x increases by 1. So my slope is actually 4 over 1. So I can actually plug this into my equation. Instead of y equals mx plus b, I can now have y equals 4 over 1x plus b. So all I need now is I need to find the b. But before I do that, a lot of you are going to write the 4 over 1 simply as 4. So you can do that as well. To find the y-intercept, I'm going to use the other information I'm given. It tells me that the graph passes through the point 2, comma 1. This is the ordered pair 2, comma 1, which represents some information. The 2 represents the x-coordinate. The 1 represents the y-coordinate. So the x and the y actually are represented by numbers that I can plug in to my equations. Instead of y, I can plug in a 1. Instead of x, I can plug in a 2. So if I do that, my equation will now look like 1 equals 4 times 2 plus b. Well, 4 times 2 is simply 8. And to solve for b, I just need to get rid of the positive 8, and the opposite of adding 8 is to subtract 8 on both sides. And 1 take away 8 gives me negative 7. So my slope is 4 over 1. My y-intercept is negative 7. I just need to put that information together into a final answer, which will be y equals 4x minus 7. Let's look at number 2. Number 2 says the function with a rate of change of 3 over 2, whose graph passes through the point 4, comma 10.5. Once again, I'm finding a linear function, so I need to find the slope and the y-intercept. For number 2, they actually tell me what the slope is right away. They tell me with a rate of change of 3 over 2. Rate of change is just another word for slope, so I know my m is 3 over 2. I can go and plug that in to my equation. To find the b, just like number 1, I'm going to use the ordered pair they gave me. They tell me the line crosses through the point 4, comma 10.5. This is my x-coordinate. This is my y-coordinate. I can now plug those in. Instead of y, I plug in the 10.5. Instead of x, I plug in the 4. Now, to take care of this multiplication, remember 3 over 2 is a fraction, but 4 is not. So you can just write the 4 as a fraction. There's a 1 underneath. Do the top times the top and the bottom times the bottom. 3 times 4 gives me 12. 2 times 1 gives me 2. 3 times 4 gave me the 12. 2 times 1 gave me the 2. So I now have 12 divided by 2, but we know 12 divided by 2 is simply 6. And now to get this b by itself, I need to get rid of the positive 6. The opposite of positive 6 is subtract 6 on both sides. And 10.5 take away 6 gives me 4.5. So my slope is 3 over 2. My y-intercept is 4.5. I put it all together. I get my final answer of y equals 3/2 x plus 4.5. Number 3 says the function with a rate of change of 4 over 5 that has a value of 10 at x equals 10. Just like number 2, they tell me what the slope is right away. I know my slope is 4 over 5. I can plug that into my equation. Now to find the y-intercept, I have to use the other information they give me, which is a little more cryptic. It tells me that the value of 10 or it says it has a value of 10 at x equals 10. The piece in purple here is a little cryptic. What the piece in purple is actually describing is an ordered pair. They're saying when x is 10, when I plug in 10, the value I get out is also 10. So when I plug in 10, I also get a 10 out. So we're actually creating the ordered pair 10, 10. I can now plug these values into my equation. Instead of y, I'm going to plug in a 10. Instead of x, I'll plug in the 10. And then your job is going to be to solve for b. I'm going to let you finish this problem off. It's very similar to number 2. Multiply the fraction out, and then move it to the other side, and now it should get your b by itself. Number 4 says the function that has an x-intercept of -2 and a y-intercept of -2/3. This time they give me the y-intercept right away. They tell me that the b is -2/3. Quick reminder, the y-intercept tells you where the line crosses the y-axis. The line crosses the y-axis at the point 0, -2/3. I can now plug this into my equation. Instead of b, I'm now going to plug in the -2/3. I now need to find the slope, so that means I need to figure out, do I have an x or a y to plug in? That way I can actually solve for m. And it turns out that you do. There's some more information in the description. It tells me that I have an x-intercept of -2, the piece in purple here. An x-intercept is something we haven't taught you yet, but is very similar to the y-intercept. The y-intercept tells you where your line crosses the y-axis. The x-intercept tells you where your line crosses the x-axis. So the x-intercept, since it crosses at -2, and on the x-axis, the y-coordinate's always 0. So we actually get the point -2, 0. Notice something. For the x-intercept, your y-axis is 0. When it's a y-intercept, your x-axis is always 0. So keep that in mind. I can now plug this into my equation. Instead of y, I'm going to plug in 0. Instead of x, I'll plug in the -2. I now get 0 equals m times -2 minus 2/3. And now I'm going to rewrite this using some algebra. I know I have to get the m by itself, so I'm going to get rid of the -2/3 by adding it to both sides. The opposite of subtracting 2/3 is to add it to both sides, and 0 plus 2/3 gives me just 2/3. And a -2 times an m is simply a -2m. I'm going to leave you to solve the rest of the problem. You finish solving the problem for m. Remember, the opposite of multiplying by -2 is to simply divide by -2. And finally, number 5. Cameron stops to get gas soon after beginning a road trip. He checks his distance from home 2 hours after filling his gas tank and checks again 3 hours later. The first time he checked, he was 170 miles from home. The second time, he was 365 miles from home. What equation models Cameron's distance from home as a function of the time since getting gas? This last part is pretty confusing, but what they're basically telling us to do is to use a linear equation, and they want us to have the time as our x-coordinate. It says the distance as a function of time. So the distance will be our y-coordinate, the time will be our x-coordinate. And it also tells us a little bit about the problem. It tells us that Cameron kind of makes 2 checks of his gas tank to see how much gas he's used. The first time he checked his gas tank, he had driven 170 miles from home, and that was 2 hours after filling up his gas tank. So I can actually change this information I highlighted in blue into an ordered pair. After driving 170 miles in 2 hours, we can write that as an ordered pair, 2, 170. Once again, they want the time to be our x-coordinate, and they want the distance to be the y-coordinate. For the second time, I can underline in red. It says he was 365 miles from home, and he checked it again 3 hours later. So this time, it's not going to be 365 miles in 3 hours. It's going to be 360 miles in 5 hours, because it was 3 hours after his other check. And 2 plus 3 gives us the 5. So my other ordered pair will be 5, 365. Now I need to use these 2 ordered pairs to come up with the slope and the y-intercept. Well, coming up with the slope is something we did a lot in class. You're going to use the formula y2 minus y1 over x2 minus x1. Here's my x1, here's my y1, here's my x2, here's my y2. If you do the math correctly, you'll get the slope 195 divided by 3. 365 take away 170 gives you 195, and 5 take away the 2 gives us 3. And you can actually simplify this slope. 195 and 3 can both be divided by 3, and you'll get 65 over 1. Now to find the y-intercept, you're going to do just like we did in the other 4 problems. You're going to plug in one of these ordered pairs into your equation. So you can plug in the blue coordinates or you can plug in the red coordinates. For example, I can plug in the 2 for x and the 170 for y, or you can plug in the 5 for x and the 365 for y. So I'm going to leave that for you to try. If you get it wrong, no big deal. All we really care about right now is, are you putting in the effort? Or are you at least trying to do the math? We're not grading you on correctness. We're grading you on effort.